welcome you all to this webinar and thank you all for joining us today. The title of this webinar or this workshop is One Click Way to Backfill and Index Blockchain Data. And as the title suggests, what we will be learning in this workshop today is how you can backfill the entire chain's historical blockchain data with just one click. And on top of that, you do not even have to worry about setting up your data pipelines or setting up your ETL pipelines for your blockchain data. And a very plus point or cherry on top of the cake is that you do not even have to filter this blockchain data on your end or on client side. Everything is taken care of by QuickNode, by QuickNode product called Streams. So joining us today are two rock stars from the QuickNode product team, Nick Yushkevich, who is the director of product, and Gail Jenkins, who is the senior technical product manager at QuickNode. So Nick will walk us through Streams, and he will show us that how we can use Streams to backfill an entire chain's data with just one click. And then Gail will show us a preview of Solana Streams, which will change the way how you and I access Solana data. During the course of this entire workshop, feel free to ask any questions. Feel free to ask any questions or ask anything about, let's say that you want to see a particular data set to be accessed via Streams. Let's say that you want to see a particular destination which can be used to send data from Stream. Do that in the chat below. Feel free to ask any questions. So without any ado, I will pass it on to you, Nick. Enlighten us with Streams.
Thank you, Sahil. Good morning, everyone. I'm really excited to show you Streams in action. And one-click backfills is not an over-exaggeration. It is practically a single place where you just click on a combination of chains and data sets. And once clicked, it takes you to a dashboard that has everything pre-set up for you. You just connect it to your destination, whether webhooks or a set of databases we support. And also we support serverless functions where you could code any integration, whether PubSub, Kafka, you name it, or even Telegram. With all of that, you can forget about setting complicated infrastructure, polling endpoints, everything is handled for you. So I'm just going to quickly share my screen and show you around in the one-click backfills page where you could find those combinations. And then I'm going to take you through the series of actions you need to do to create your first stream and then monitor your backfill progress. Awesome. This brings me to a screen here. On QuickNode website, there is a section of streams in the products. And this landing page has this link to one-click backfills, which is an amazing collection of all data sets and chains that you could backfill with just one click by clicking on a template. Sahil, I'm really curious to know more about our attendees today and whether they want to see some particular chain or some particular data set. But if there are no preferences, I would like to start maybe with Base and show how easy it is to backfill Base block and receives data to a Snowflake database.
Yeah,
so
I think Base will be a very good example since there's so much traffic going on Base right now. So seeing that how we can just get all of that data very easily and I mean, in just one click will be very interesting for our audience, I think.
Yeah, I agree. There are some changes in the market all the time. If you go to DeFi Llama, you could check how trends are changing towards Solana recently for some use cases that were prevalent on Base. But having access to all these chains is an amazing, it would be an amazing way for you to access all these chains through QuickNode Streams. We are currently supporting 23 EVM chains, and Solana would be really soon to come addition with all the essential data. But let me just quickly pick Base here. And it shows you all the options we've pre-built for you, but it doesn't mean that you are limited to that. And I'll explain you how and why. When you click on backfill blocks, transactions, and receipts on Base, this brings you to a UI for stream creation where we pre-filled everything for you. So you don't have to figure out any kind of combinations of settings to start your backfill. So we've already selected base, main, and chain, and network. The data set includes both blocks and receipts data that are necessary for you to get all the transactions that are happening on chain and all the events. It has an elastic batch option enabled so that whenever you backfill your data and you're hitting the latest block, we're just streaming you the most relevant and fresh data as possible. And we're starting your stream from a Genesis block. So it's as easy as that. And once you go to reorg handling section, you could also modify your preferences for real-time data and how you would deal with blockchain reorganizations.
Got it. So Nick, I can see that there's an option where it says block number, and then there's another option which says stream end. So does that mean that I can only stream the latest block, or how does that work? How does that option works?
Yeah, you're bringing up a very important point. So streams work in a guaranteed exactly one sequential delivery way, meaning that we're starting to stream all your data from a block reference specified as a stream start. In this example, we're starting from Genesis block, from the first one. But you could also pick an arbitrary one or start from latest if you want to just get at the tip real-time data, let's say. You could also specify a target block number if you know let's say, contract creation reference. So for example, Uniswap was deployed at 9 million block, and you could start your stream that is filtered to Uniswap data at exactly this block, meaning you save on bandwidth and resulting costs because streams are charged per gigabyte of data. And each plan has recently received an included traffic for everyone. And I'm really thrilled to see more and more people discovering the value. And you could also end your stream if you just want to have a portion of this data to be delivered. And in that case, we'll show you the progress as you approach the end reference.
Got it. So just a follow-up question on that. You mentioned a really good point that if you know a block reference of a smart contract deployed at a particular block. So let's say that I don't know about that when that particular smart contract was deployed, and I am just filtering for that particular smart contract from, let's say, Genesis block. So obviously, until the block when that particular smart contract was deployed, I will get no data because Stream is filtering for that. So will I get charged for that particular phase because Stream is still filtering the data, right? But I'm just not getting delivery for that data because I want a particular smart contracts data. So will I get charged for that particular period?
Oh, not at all. In fact, let me quickly switch over to another use case, and then we'll show you the block with receipts data. Because in this particular case, we're not filtering anything. We're streaming raw data as is. It's more of an ELT pipeline. So you extract the data with our help, you load it to your destination, and then you transform it. This is really helpful for use cases when you do exploration of data and you don't really know what exactly you're looking for. But if, let's say, you just need Uniswap or transfers, you could find another template really helpful for your use case. For example, backfilling all the transfers on base for ERC20, 721, and 1155 standards of tokens for NFTs. If you click here, in just one click, you could start the stream with a predefined filter that parses everything in the stream data using this JavaScript logic and puts respective transfers for each of these types of tokens into these arrays by filtering log topics corresponding to signature events for the transfers. I could illustrate this really easily by clicking run tests and run test and showing you an example payload that you will get on your end. So you will receive the array of ERC 1155s, and you could also download this file and inspect its contents very easily. And to illustrate the differences, I could also pick another block, let's say at 10 million reference here, and they would return you completely different payload. Instead of getting 54 kilobytes, you would just filter down to 5 kilobytes. And there's always an option for you to compress this data and save even more on bandwidth. So let me switch back to this example where we had base block with receipts and just show you streams and actions, because I feel like we've been talking about filters for quite a while, and I'm really excited to show you things in action. On the next step, you could pick your destination. We support a variety of those, and you can also code your own integration with any tool using Node.js, Python logic within our serverless. I would like to kick this off with Snowflake. And just for the purpose of demo, I had already pre-filled everything for exactly the same stream as I was showing you, with the warehouse references, host account, and so on. Once you hit test destination, streams will confirm that we could connect successfully to this warehouse. And once I click create a stream, you will see that the AbleSoft stream has been created, and we are now streaming these blocks sequentially from block 8 at this point, or 10, down to infinity, because we're not stopping our stream. In a second, you will see this screen updated. And as we go to Snowflake and monitor the query history, we can see that we are already executing the base webinar queries, and we're putting data in. One important distinction: when we were creating a stream, I quickly skipped over an important parameter. In the stream settings, there is a way to pick a number of messages to be streamed together. There are some network overheads depending on the destination, and some destinations would process batches of messages more effectively. To update your settings and increase the number of messages we're inserting at the same time, you could increase the payload batch size, which would make it so that we insert 100 of messages into Snowflake altogether. And once I save changes and resume my stream, you could see that this stream is now going to accumulate 100 of blocks and then stream them all together. And you could see that this will affect your backfill rates. You could also inspect your backfill rates here on metrics.
So, Nick, I have one question.
Sure.
So you mentioned batch size. So the batch size, it will obviously depend on the processing the destination platform can handle, right? Because I mean, we can just enter 1,000. We can be sending 1,000 blocks at one time, but the destination should also be able to handle that, right?
Exactly.
So
this is a great point.
Do you have any preference, or do we recommend any destination which can handle like larger batch sizes or bigger batch sizes?
This is an excellent point. This always has to be a combination of you observing how well you're egressing the data and how well you're inserting it. In Snowflake, there is a way to monitor the rates of how your warehouse processes this data and how long it takes for the warehouse to execute it. There are a few settings you can tweak. If we talk about Snowflake specifically, you could always increase the size of your warehouse, which would make it more performant for your use case, especially if you're dealing with large inserts. This would incur more credits on your side if we talk about Snowflake. But on stream side, it won't change anything. We still charge you for the same data rates. And you could observe whether those changes in batches affect the rate of your like block delivery. So in this particular example, we're delivering those blocks in bursts of 60 blocks a second, which includes those batches in there. So it would be something like 1,000 blocks delivered every few seconds or so. So we had increased our backfill rates right away by changing the block payload batch size. And we could try a larger value. There is a theoretical value of 1,000 messages, but it doesn't limit you from going even faster than this, because you could always spin up an additional stream and egress this data out of us at a higher rate. So you could backfill with multiple streams and target it into the same warehouse. And in our example here, we're putting data into Snowflake schema here called backfill demo base webinar. If we preview the data, you could see the data is flowing in nicely with the block number reference and everything in this JSON. Conveniently, I created this SQL query that can help us check how far we are in terms of backfill. Like, what are the ranges of blocks that are already in here with all the receipts, and where are the gaps? So I could just use the name of our table and execute the same query and see how far I am in terms of our backfill progress. And as we can see here, there are some improvements with the query that I could do because it duplicates some counts for no reason. But we're practically covering all the blocks from range 1 down to range 16,000 at this point. So we've already extracted 16,000 blocks. And as I'm clicking through, I'm just trying to show you our current reference. So we're sitting in block 21,000. So this illustrates how easy it is to backfill with streams without having to figure out anything whatsoever related to RPC requests or dealing with endpoints or any other limits. And I'm really excited to show you that, guys, in action, and also get to hear your feedback or questions if the audience may have it before I take you to another example.
There is a question from the audience, and it's from Peter. Peter asks that could we do something like an export of all the logs for a particular event type, like just logs for particular event types, like ERC20 transfers or 721 transfers?
Yeah, absolutely. Right now, we're extracting all the raw data, right, without any sort of filtering, any modification. Let's take a look at what it would look like if we backfilled all ERC20, ERC721, or 1155 transfers into Postgres, because that's exactly what we're going to do here with this template. Once clicked, we'll have this filter that checks log entries for ERC20 signature. And if it matches all the number of parameters for transfers on ERC20, we're just going to parse those transfers and push them into their respective arrays and then pass it over. So I'm going to illustrate the backfill of all ERC20 transfers to Postgres. Once I hit next, I could pick Postgres and then fill in all the details. Conveniently, again, for the purpose of demo, I filled everything in. And once I click on test destination and I see that everything works fine, I could go ahead and create a stream. Right now, we're streaming everything into this Google SQL instance that had created, and the stream had created a table called, as we scroll down, backfill ERC-based webinar. So once I go and update our tables here, we could see that this data is flowing in nicely. We have the block numbers coming in. The thing is, right now, we are scanning across all the first blocks. And you can see that even if we have a batch size of 1, we're quickly filtering all this data. So the first blocks on base won't likely have any transfers. And if I switch over to some later block, or for example, test this filter with the block reference of, let's say, 10 million, I could see if this block has ERC transfers, and we could see that there was at least one ERC 1155. So let me quickly update my start reference and then resume our stream and then make sure that the data is flowing in. Because all the initial blocks, they didn't have any sort of transfers at all. And us updating this reference would make it so that we start scanning from a block 10 million. Let me see if we're getting the data. Well, actually, there were some transfers from in earlier blocks. I'm not entirely sure why the start reference wasn't updated. Let me try pausing it again and then resuming it. Oh, because I haven't saved the changes, that's why. Yeah, and once I resume it, we will continue our backfill for all ERC transfers from a block 10 million. Yeah, and we can see that in this range of data, we have way more ERC20 transfers. And again, you could always filter data in a bulk. So playing around with payload batch size and making sure that the setting works just fine with your destination and increases your throughput rate is a nice optimization strategy once you want to go faster. And then once you exhaust all the potential that the payload batch size carries, you could deploy additional streams that are targeting the same schema, but for a different range of data. And you could always monitor your metrics here. You'd have to refresh this page to see how those changes in the batch size affect the processing rates. But yeah, this practically concludes my demo of a simple example of backfilling blocks and receipts with just one click on of this template, and then using filter stream for ERC transfers and delivering this data to Postgres.
Good. So thank you so much, Nick, for showing us that. And we will wait for audience to ask any questions. But until they ask questions, I'll just be an advocate from audience's side and ask you a few questions. So it's up to you, Nick or Gail, anyone of you can take the question. So I know that we can do all of this via WebSockets as well, right? We can set up a filter for WebSocket and backfill those data. So why would someone use streams? Because the thing is that people know how WebSockets work already. So why would I, as a user or as a consumer of blockchain data, use streams or try streams? And then the other question is, sorry, but this is related. So other question is that, let's say that you showed us two examples of destination. One was a Postgres instance and another was a Snowflake instance. So what happens if my Postgres provider goes down for a couple of minutes and I, on the user side or client side, have no clarity of what went wrong? Because I, as a user, don't know that if something went wrong with streams or if something went wrong on Postgres side. So is there any mechanism where streams can still try to reach my Postgres instance, or is there a way where I can see error logs that what went wrong where?
Yeah, this is an excellent concern and question. WebSockets is a nice way to get this data streamed to a number of libraries, and this is great for mostly real-time data. But as we've learned from talking to our customers and observing their use of RPCs, usually there are lots of errors which related to retries and polling and in general networking. So WebSockets as a great tool is not as reliable as something as streams. In our case, we integrated this technology with a guaranteed delivery, meaning that if something happens, we will continue from the last technology block. And I'm going to give you a really quick demo of how easy it is to deal with any sort of errors that can arise when your stream runs into any networking issues or something else. So I'm going to share my screen and show you a webhook server that is spun up with typed webhook tools. This accepts incoming messages to this URL, and conveniently enough, streams can also stream to a webhook server. We could pick some other templates here, let's say backfilling blocks and transactions. And once we go to the next stage, we could pick webhook and put it in as a destination URL. Once we test this destination, this webhook server.
Nick, sorry to bother you, but would you like to full screen the browser window so that our viewers can see it better?
Sure. Let me figure out how to do that. Can you see my screen right now?
Yes. Yes, it's
okay.
Much better now. Yeah.
Perfect.
Thank you.
Yeah. So what's happening on the right side is I have a webhook server that accepts incoming messages from a base, or sorry, in this case, I'm actually using Blast mainnet block, I think. And once I hit create a stream, this stream will be streaming all blocks on Blast chain. And we can see it streams data sequentially for every incoming block. But what happens if something goes down on the webhook or receiving side? The stream will quickly go into a terminated state, meaning that we've delivered successfully 55 blocks in this data range and something went wrong. With the way when we expected you to acknowledge that you received this payload from us. And in that case, we can see that there is a 400 HTTP status, meaning that something went wrong with the webhook and it doesn't receive any requests anymore to this address because it went down. So we could easily deal with this issue by submitting a new URL and resuming our stream. And once we resume it, we're going to continue from the last process block, and everything goes smoothly. You don't have to deal with any retries, any errors. Streams will handle it if you run into any issues with the destination.
Good. This is perfect. So what if I was able to retrieve my older webhook URL? Is there a way that I can have retries set up for the same URL without changing the URL? For example, I can just retry to that same destination after a set period of time or after a set timeout?
Absolutely. In fact, some of our customers deal with large batches and longer processing times. As some of you may know, Arbitrum blocks are produced really frequently, and sometimes processing large batches of Arbitrum takes time. So you could always modify your timeout period and increase the number of retries and wait time in between statuses that are other than HTTP 200, meaning something that goes wrong on the webhook side, but the webhook is still reachable. So we could increase it to like 30 seconds and then update those changes. And once updated, we could force streams to wait longer in between any attempts. But in our case, luckily, this webhook server still runs just fine, and we are delivering data as we speak.
This was very insightful. So I can see that Streams is a very powerful tool using which you can not just backfill, but even if you were to get the latest block data and just go from there, just keep on getting the latest block data, you will be able to do that as well. And you can also put filters. That's just something else. So thank you so much, Nick, for walking us through Streams and showing us how we can use Streams to backfill data or even like backfill certain kind of data. So now let's go on to Solana. So Solana is a beast of a chain, and getting data from Solana is a headache for everyone. And everyone knows this who has been working with Solana. And working with Solana WebSockets is a completely another story. And dealing with those reconnects, dealing with those disconnects of WebSockets, it's very painful. So Solana Streams addresses all of those and more. So Gail, walk us through what Solana Streams is all about and how it can change the way we access Solana data.
Absolutely. Let me just quickly share my screen. So we're excited to be onboarding users now to Solana Streams. You can visit quicknode.com/streams/Solana in order to get to this page and then fill out this little form in order to sign up for beta. But I want to give you a demonstration on how you can actually use Solana Streams and what this means for users. So on Solana, we have two different data sets right now that we're supporting. One is the block data set, which contains all the data within each Solana block. And we also have programs and logs, which let you access a curated data set of program interactions and logs. So for this example, I'm going to stream balance transfers on Solana. And I'm going to start from a historical block moving forward. One of the key benefits of Solana Streams is the ability to target not only current blocks as they happen, but also historical data from the past. You can choose to either stream the raw data, But with Solana, that data can be fairly large. Some of the blocks are over 50 megabytes. So we have the flexibility of being able to use filters to narrow down that data, to transform it before sending it to our final destination. So in this example, we're going to look for any Solana balance changes in the block, and we're also going to look for any token balance changes in the block. And we can test that and get a sample of what the output will have. So we do have balance changes happening. And what I'm going to do is send this to a webhook server. So as you can see, we can now see the data coming in. And what we're getting is a curated list of balance changes that happened in the block. So we're not streaming all the data from the block to our webhook server, but we're actually just streaming this custom data. Sorry about that. It's coming in so fast. Let me just pause that. Yep, and this is historical data. So that's an example of getting data from the past, transforming it, extracting the information that's useful, and then sending it on to its final destination. So that wraps up the demo of Solana Streams. If you have any questions, though, feel free to drop them in the chat.
Yeah. So Gail, this ignited a query or question in my mind. So since you were getting the historical blocks, and Nick showed us that we can get historical blocks in batch sizes, right? So let's say that we are getting blocks in a batch of 50. We are getting 50 blocks at one time. But we are not setting an end block for the stream. So it will just go on for all the latest blocks which are coming in. So what happens to our stream when the stream reaches the latest block? Because our blocks, our batch size was set at 50, right? And we cannot have 50 latest blocks. So what happens during that point?
So at that point, what will happen is it will go back down to one. If you have the elastic batch setting activated, it'll go down to one block per message once you reach the current block. The thing that I wanted to mention, and I overlooked when I was going through the demo, is that we're working on adding some new features to the Streams filters. It's powerful as it is now, but for EVM and Solana, we're working on simplifying the experience by adding some useful helper functions, and also to enable new features that will assist in decoding logs, transactions, and account info by adding ABI and IDL support within the Streams filter.
Is Streams, or are we planning to launch Streams on other layer ones, like the Move layer ones or UTXO chains? I know that we already support Bitcoin, but are we planning for other UTXO or Move chains?
So in the future, we do plan on supporting all of our chains on Streams. We do have Solana now in beta. We have Bitcoin available in Streams. We do have the Tron EVM available on Streams, but we do plan to expand to other chains and networks also.
Got it. Yep. So thank you so much, Gail, and thank you so much, Nick, for those demos. And now we will open up the stage to our audiences if they have any questions. And if they don't, we will have this recording available on our YouTube channel. And we always are eager or happy to answer any questions coming in to us via our Discord or Twitter.
Sahil, I see there is a question from Carl on how to avoid overloading the destination services with the amount of data Solana Stream will send. There are a few strategies, if I can take this answer. Controlling the destination throughput and filtering your data with granular filters on stream side will ensure you're not overloading anything. But yeah, this is a really common issue. Even with Arbitrum, we see that some customers complain about your stream is sending data too fast. We cannot handle it. Setting a larger batch size also helps, and processing things in batches because of the back pressure issue that is caused by too frequent pushes from our side. Increasing this batch size will likely make it more performant on the destination services side.
All right. And we have another question from Kagmini. And the question is, what's an ideal use case for these one-click backfills? Like, what's the most common use case we have seen our builders build using these one-click backfill templates?
I can take that one. So a use case for the one-click backfills would be anytime that you need to have access to the historical data for things like analytics, or you want to build a data set for any purpose. That would be a use case for the one-click backfills. We see users who have used RPC to get like all of the transactions or logs historically throughout the chain, transition over to using streams, and then they get the added benefit of us pushing the data to them complete. They're not having to poll for it. We just stream it directly to their destination with all of the features that Nick mentioned earlier, like the guaranteed delivery, the ability to set batch sizes, etc.
So basically, anyone who wants historical blockchain data to be indexed, but just in a faster way and in a more convenient way, so they can just click a button and get all of that data flowing to them.
Exactly.
But I think this question that was about like what's the use case for one-click backfills, and Carl's question, which is how would you compare and contrast streams with other solutions like subgraphs? They're really interrelated. Subgraphs are great when you know the granular data and you follow the specification of contract. There are so many popular ones that are powering ecosystems like Uniswap. But what we've seen is that developers struggle with re-indexing subgraph data whenever there is a subtle change on the contract side. What Streams allows you to do is to follow the raw data and also own this on your destination. So instead of you having to re-index and wait for subgraphs to be spun up and then wait for re-indexing all this data from scratch, in Streams example, you would own this data and you would be able to run any sort of mapping logic yourself. So also, you were able to see how fast it is to index some simple data sets such as ERC transfers. We also have templates for PancakeSwap, Uniswap, and we keep on adding more and more of those. There are some downsides to Streams that in the way that you have to load them somewhere to be able to access this data. But we also see that our customers are figuring out the use of key value store. We recently added the managed database service in our fleet of data products. And we see some nice emerging use cases where customers are putting data into key value store and create APIs to access this data through functions. So I would say that subgraphs are great when they are limited to a specific contract, but they are prone to re-indexing issue when it comes down to changing things, especially for rollups. We've recently released the managed rollup product. We see that there is an emerging need in adapting those smart contracts before you go live with your chain. And in that case, Streams can help you source all this data and run experiments on how you would like to slice and dice it.
Good. So Nick, I have something to add to that. So I think that subgraphs are like indexes, right? So you could build something like subgraph using Streams, something like subgraph using Streams. Plus another thing is that subgraph, since it's indexed data, there has to be some delay between the latest block getting indexed onto subgraphs and then you accessing that block data via subgraphs. Whereas with Streams, you get that latest block data streamed directly to you as soon as it happens or as soon as it is confirmed on chain.
Exactly. That's a good way to highlight the difference. Subgraphs is just for a great for granular indexing, but Streams is a wider use case tool that you could use for indexing, for real-time data, for various use cases.
So thank you so much to everyone who joined, and we will see you in the next one, in the next workshop.